based on the Global Navigation Satellite System, also known as GNSS. So, GNSS is a system of satellite technologies that provide precise location data for points on Earth's surface. Examples of GNSS are the US Navstar Global Positioning System, also known as GPS, and other ones are Russia's Global Navigation Satellite System, known as GLONASS, and Europe's Galileo GNSS, and China's Beidou, also known as Compass. So each satellite, like we see here, continuously transmits positioning data. The receivers on the ground, like in this example, connect with at best 4 satellites. So here we see 4, and there's a receiver on the ground on Earth. Three-dimensional coordinates are calculated through trilateration. So here the figure is expanded, and we could see here that the Global Positioning System satellites orbiting 20,200 kilometers above Earth broadcast timing signals that are picked up by a receiver on the surface. The time it takes the signal to travel from a satellite to the receiver is used to calculate a distance circle on the surface. So here in this figure, we do see 3 distance circles from 3 satellites. Where the distance circles at least 3 satellites overlap, the exact location of the receiver is determined through trilateration. So again, 3 circles overlap, and that's how they are able to identify the location accurately. And then they have the 4th satellite to check it. So the GPS system was developed in the 1970s by the US Department of Defense, and it is operated by the United States Air Force. So again, when this was created in the 1970s, this was used to aid in navigating aircraft, guiding missiles, and controlling ground troops. So this system is based on a constellation of at least 24 high-altitude satellites configured so that a minimum of 4, preferably 6, are in view from any position on Earth. Currently, 30 satellites are active, with several older satellites still in orbit as backups. The simplest GPS units determine position to within about 5 meters. And also, the more channels a GPS unit has, the more satellites that can be tracked and the better the accuracy. Inexpensive units now have 12. So increasingly, mobile devices such as tablets, cameras, and cell phones contain built-in GNSS receivers. The next concept we'll be looking at is the Wide Area Augmentation System, also known as WAAS, and this was developed by the United States Federal Aviation Administration. And this was to increase the accuracy of instrument-based flight approaches for airplanes. So again, this is a network of ground-based reference stations that monitor and correct GPS signals. So there are several dozen ground-based reference stations across North America monitoring GPS signals and then transmitting correction messages to the satellites. Talking about is called CORS, and this is called Continuously Operating GPS Reference Stations. So NOAA manages a system of permanent and highly accurate GPS receiving stations. These highly accurate units can detect location differences of less than 1 centimeter of latitude, longitude, and elevation. And CORS constantly monitor changes in ground surface by slight differences in latitude, longitude, and elevation. Their uses include the long-term monitoring of slight changes in the ground surfaces caused by lithospheric plate movement or the bulging of magma below a volcano. The GPS modernization program. The United States has an ongoing modernization program for its GPS system. The upgrades include replacing older satellites with newer ones that provide greater accuracy, and also it includes a fourth civilian broadcast GPS signal that is compatible with the GNSS of other countries. The first new generation GPS satellites were launched in 2018, and others are scheduled to be in orbit by 2034. For GPS applications, since the 1980s, scientific and commercial applications far outnumber military uses. Practically everything that moves, such as airplanes, your cars, trains, vehicles, can be equipped with a GPS receiver. When your cell phone location tracking is activated, it's a fairly simple matter for a commercial search database to direct you quickly to the closest coffee shop or to the nearest store with the item you want to buy. Applications. Examples of applications are earthquake forecasting, ocean floor mapping, tracking COVID-19 pandemics, and natural disasters such as floods and hurricanes. And for GPS display of latitude and longitude with greater accuracy, coordinates frequently reported in more detailed decimal units. And that's it for our GNSS lecture. It is short. Please do the online readings and the assignment for our lab course. Thank you for watching.